Kindly confirm at your end whether the slide is visible at your end.
Sir, screen visible, sir.
Thank you. Good morning, students. Welcome to another session of CPCE. Today we are going to start the fifth unit, and today is the first session of your fifth unit. And the fifth module talks about machining time calculation. And in the syllabus, when you look at it, has the following content that you are seeing in the slide: estimation of machining time, importance of machining time calculations, and the calculation method for various operations like lathe, drilling, boring, and then finally we have machining time calculation, like machining time calculation for milling, shaping, and planning, and finally for grinding. So three sets are there. So you have three different type of machining time calculation patterns based on the type of machining operation you take. So when you look at the formulation of this particular module, you can easily find it, how it has been classified. Lathe operations, drilling, boring are classified in one category where the process seems to be same regard to machining time calculation. The second set is the procedure of machining time calculation will be similar for milling, shaping, and planning. And finally, you will be having for grinding operation. Now, before going into the machining part, the problematic version, we have to be careful with some of the terms that are used in machining. What are the key terms, parameters, what we use to discuss when we talk about machining operation? So we will start with the essence of this module, which talks on machining time. Just wait a minute, sir. Energy. So when you say about talk about machining time can be defined as the time that is required or taken for completing a machining process on a component. So in a simpler version, we define it as the time which machine works on the component. To complete the entire operation, what is the total time taken? That is known as machining time. And usually it starts from the moment the tool touches the workpiece and when it departs away from the workpiece. So that is the time usually taken for machining. Now, when you look into the terms or the parameters that are considered for machining and what you should be aware of, it is a mandatory term, but that you should be able to define. Because when you go into an industry or a production or a shop floor or even into a quality, basically they look for the fundamental understanding of these parameters. Most of the time we are familiar with the terms because in number of occasions we come across these technical terms. But when you are asked to define it, there you face the problem because the term seems to be familiar, but we find it hard to put it words to define it. Therefore, it is more important to understand how the definition flows. In what pattern you are supposed to remember these definitions. So, in that case, the terminologies what you should be knowing are length of cut, cutting speed. In some cases, we even take it as spindle speed, length of cut, cutting speed, speed, depth of cut, spindle speed. These are some of the terms that are most frequently used when you talk about machining time. And then we have approach length, length of workpiece to be machined, and overall travel. So how you are defining all these terms? When you look at that, suppose consider this rectangular block, what has been highlighted now is your workpiece. This is your workpiece, and you are having a tool. This part is your tool. Now, when you want to define the terms, initially, when you set the tool, after setting up the tool, when you move the tool towards the workpiece, this portion of length traveled by the tool is called as over travel. Over travel. And the minimum portion of distance that is available, that is the distance from the point where the tool starts to touch the workpiece to the portion which is available at the center of axis of the tool. This distance is called as approach. So when you carefully look at the diagram, you can find that the tool touches the workpiece, but still the axis, the center point of the tool or the axis of the tool is still away from the workpiece. So this distance is called as approach. Any other distance that is moved from its base location, that is called as over travel. And this length, the entire length of your workpiece is called as the length of cut. The total distance that is moved over the workpiece. And again, after cutting, when your tool comes here, you will not remove the tool at once. You will go for certain distance because the tool should not make impact with the workpiece. You will move further to some distance. That is again called as over travel. So starting from over travel on one end to the over travel on the other end of the workpiece, the total distance is called as length of cut. So total tool travel, total distance of travel by the tool or the total distance covered by the tool is summation of the length of workpiece plus the approach, the small distance what you're seeing here, plus approach plus the over travel on either side. When you combine this distance, it is called as length of cut. So generally talking, when you go in the industry or when you face any interview and when someone asks you what is the length of cut, then you should be able to define it. And mostly what happens is, most of the students, when they are asked to define what is length of cut, they usually say that length of cut is that portion of material removed along the length of the material. ஒரு ஒர்க் பீஸ் இருக்கு, அந்த ஒர்க் பீஸோட டோட்டல் லென்த் என்ன ஆகும், அந்த லென்த் கட் என்கிற மாதிரி சொல்லுவாங்க. That is called the length of cut or the distance traveled by the tool, whereas that is wrong answer. So you should be careful enough to define the terms. So length of cut na enna அப்படினு சொன்னா அது உங்களுக்கு சொல்ல தெரியணும். ஒரு டூல ஒர்க் பீஸ் கிட்ட கொண்டு வர்றது, that distance is called as over travel. ஒரு particular period of time ல பாத்தீங்கன்னா the tool will touch the workpiece but not its axis. So the distance between that axis and the point at which the tool touches the workpiece, that is called as approach. அதையும் சேர்த்துக்கணும். Plus you have to add length of the workpiece. எந்த டிஸ்டன்ஸ்க்கு workpiece மேல நீங்க ரன் பண்ண போறீங்க, that distance again you have to take. Machining பண்ணி முடிச்ச பிறகு you will not reverse the workpiece or reverse the tool. You will go forward beyond the contact of workpiece. for safe landing. Again, that is called as over travel. So this you have to remember very clearly and precisely. So whenever any person asks you what is length of cut, your answer should be length of cut is the square of length of jump plus plus the over travel of the tool. So when you combine all these three, you will get length of cut. Now the second parameter is cutting speed. Cutting speed is defined as the relative speed between tool and workpiece. The relative speed between tool and workpiece. Coming for feed or feed rate. Now when you look into this length of cut, it is usually measured in mm, always measured in mm. Cutting speed, it is said in RPM or mm per minute. Then when you come for feed or feed rate, distance through which the tool advances into the workpiece. You are having a material and you are trying to move the tool towards the workpiece. Then the speed at which you are giving the movement to the tool towards the workpiece, that is called as speed or feed rate. It is usually measured in the in terms of distance per revolution. When you are standing before a lathe, you will be increasing and the tool will be moved in linear direction. So it is measured as mm per revolution. How much revolution you are giving in your steering, or it is measured in mm per minute. Now the total thickness material that you are removing in a single cut. Depth of cut is the total amount of material you are removing in one cut or thickness of material. Now this depth of cut is always perpendicular to feed direction. So when you go for unit, length of cut is measured in mm, cutting speed is measured in RPM, feed and feed rate are measured in mm per revolution or mm per minute, depth of cut is measured in mm. Now coming for importance of machining time calculation. Why it is important to calculate machining time? The first point is to find out the machining cost. What will be the total cost of my machining? So when you know what is your machining cost, then only you can fix the price of your product. Or even if you are a sub vendor, you are doing a job order, what should be the revenue you should be taking from the person who is giving you order? So that calculation can be done. That revenue generation can be arrived only when you have the machining cost. So therefore, machining time is calculated to arrive at the cost, and then it is used for reduction of total manufacturing time. To optimize the machining process, you have to go for optimized level of machining time. Therefore, if you know what is machining time, you can easily identify whether the process is done in proper speed or whether it is delayed. If the manufacturing time is very high, then the production time taken will be high. And when production time is high, ultimately there is no doubt that your cost of production is going to increase. Therefore, to optimize the process, it is very much mandatory that you should have to reduce the total manufacturing time. And for reducing the manufacturing time, first you should know what is your machining time. So without machining time, you cannot do any other thing. So third point is obviously related to the first two. Simple. When you are reducing the manufacturing time, then what you are doing? You are increasing the productivity. Right. Now, when you decrease the manufacturing time, you are increasing the MRR. MRR is nothing but material removal rate. Now, machining time, other benefit is it is done to reduce the machining cost without compromising on quality. The product quality what you require should be maintained, but that should be maintained at minimum cost. So these are some of the benefits. And the last point is obviously a generic statement. Everything is done for profit, to improvise the profit. That is the reason why we are going for machining time. Now, in lathe operation, you are having 5 different types: turning, chamfering, facing, knurling, and thread cutting operations. And for all these 5 different type of operations, you should be able to estimate the machining time. Now, always remember when you go for an problem, that you have to remember the basic formulas. The problems will be very simple, but it will not be to the maximum level. You cannot expect 14 marks problem. It may be a subdivision of 1 or 2, but the application of the formula is very simple, and it is as usually I say, rather to stick on with this descriptive type of questions, it is better if you have proper understanding. Seeking for problematic solutions will give you and fetch you more marks when compared to descriptive type. But the only thing is you should be very careful with the basic understanding. So there are certain basic formulas what should you be knowing for arriving at the machining time. Now this problem what you are seeing in your slide is a problem asked in 2009 in analysis. Right? This I have taken to show you that how simple the nature of problem is. Now when you read the problem, it says estimate the machining time to turn a 3 centimeter diameter mild steel bar 10 centimeter long down to 2.5 centimeter in a single cut using high speed steel tool. Assume cutting speed of tool to be 30 meter per minute and a feed of 0.4 mm per revolution. So this is your problem. Now when you go into a problematic version, it is very important that you have to take care of the unit that is given in your problem. First, look for the units. What is the base unit that is specified in the problem? And remember that your solution should be in mm. So wherever possible, where there is a deviation in units provided, please convert it into mm. That you have to remember in your mind. Now in this problem, when you read, it says you have to calculate the machining time. The workpiece that is given to you is a mild steel bar, and the given diameter of the bar, the material that is given unto you is the 3 centimeter. So convert it into mm, so it will become 30 mm. The diameter, given diameter is 30 mm. Given length is 10 centimeter, so 100 mm. And you are required to convert it into 2.5 centimeter. That means 25 mm. You have to reduce 30 diameter to 25 diameter. So 5 mm you have to reduce. And the problem says that you have to do it in a single cut. Only once you are given chance, in a single cut, you have to remove 5 mm. And the tool that is used is high spindle speed tool, and the cutting speed is given, and feed is given. Now, when you look into the problem, the basic formula for turning operation is the measuring time T is equal to capital L divided by F into capital N, where capital T is the measuring time, capital L is length of the workpiece, small f is speed, and capital N is spindle speed. Capital N is spindle speed. Now in this formula, you have to remember this formula. You have to have this in your mind, because these formulas will not be given. It has to be uh, remembered by you, and you should be able to recall these formulas. Now here T is the time what you have to calculate. L, it is given in the problem. L value is given in the problem. F, speed, it is given in the problem. N, it is indirectly given. N is indirectly given. There is another formula. இதோட பேஸ் ஃபார்முலா பாத்தீங்கன்னா என்ன ஃபார்முலானா கட்டிங் ஸ்பீட். கட்டிங் ஸ்பீட் இஸ் ஈக்குவல் டு, அதாவது ஃபார்முலா என்னன்னா எஸ், எஸ் இஸ் கட்டிங் ஸ்பீட். கட்டிங் ஸ்பீட் எஸ் இஸ் ஈக்குவல் டு 5dn by 1000. இதுதான் ஃபார்முலா. கேபிட்டல் எஸ் இஸ் ஈக்குவல் டு, இந்த 5d இங்க போயிடும், 5d இன்டு கேபிட்டல் n by 1000. அதுதான் ஸ்பிண்டில் ஸ்பீட். ஸோ அந்த ஃபார்முலால இருந்து இதை என்ன கொண்டு வந்திருக்காங்க. ஏன் அதை கொண்டு வந்திருக்காங்கன்னா, in our problem cutting speed is given, s வேல்யூ கொடுத்துட்டாங்க, அதனால அந்த ஃபார்முலாவை ரிவைஸ் பண்ணிருக்கு. இதோட பேஸ் ஃபார்முலா பாத்தீங்கன்னா என்ன ஃபார்முலா, கேபிட்டல் S is equal to 5dn by 1000. இதான் ஃபார்முலா 5dn by 1000. ஸோ அதுல இருந்து n எடுக்கிறோம். ஸோ n சப்ஸ்டிட் பண்ணீங்கன்னா 1000 into s given in the problem is 30 divided by pi into what is your diameter, 30. So you are getting 318.31. Now please remember here, when you substitute this, you have to directly substitute the value. Don't go for unit conversion here. S order base unit meter per minute. Spindle speed order base unit is meter per minute. Right. Therefore, though there is no need to convert here. You substitute the same value and your value will be 318.31. Then go for machining time calculation. You have all the values. When you calculate, put together all the values, you will be getting the final value. That is your machining time. So when you substitute, you will finally get 0.785 minutes. Now coming for external relief turning. When you look at the diagram, this is called as external relief turning. You are having a sketch here where at the center portion you are removing certain material diameter. The diameter of the certain portion is minimum when compared to other two sides. If we consider this portion as A, this as B, this as C, then the B portion is having diameter which is having external relief turning. Right. For this particular area, you are removing the material diameter. So now you are asked to find the time to turn the external relief shown as shown in the figure. The material is given as mild steel, cutting speed is given, and speed is given. Right. So what is the formula for calculating the speed? N is equal to 1000 into S. S is cutting speed divided by pi d, where N is spindle speed. N oda பேரு spindle speed பா, S oda பேரு cutting speed. Don't confuse with this. Capital N is spindle speed. S is cutting speed. So N is equal to 1000 into S by pi d. You are substituting all the values, you are getting this value. And you substitute in the formula T is equal to L by F into N. So you will be getting the final answer. So that much simple it is. So in turning, you are having only two formulas. Calculation of spindle speed, capital N. N க்கு ஒரு formula. Cutting time or measuring time calculate பண்றதுக்கு ஒரு formula. Right? So you have to memorize these two formulas. There is no other way, right? These two formulas is sufficient for you to solve the problem related to turning. And when you come for chamfering operation is again limited when compared to the other types. When you look at here chamfering, there is a diagram given for you. The problem says, read carefully the problem. A 25 centimeter diameter bar is revolving at 65 rpm. So is revolving at 65 rpm. rpm னு கொடுத்திருக்கான். So rpm இருந்தா அது என்னது? Spindle speed, capital N. நல்லா கவனிங்க, இங்க வந்து revolving at 65 rpm னு கொடுத்திருக்கான். அப்ப இங்க சிம்பல் என்ன யூஸ் பண்ணிருக்கான் பாருங்க, capital N. Previous problemல போங்க, cutting speed is equal to 60 meter per minute. Meter per minute னு கொடுத்திருக்கான் cutting speed. அதனால நம்ம என்ன எடுத்துருக்கோம்? Yes. So careful இருக்கணும். You should be able to designate the given values properly. So இங்க rpm இருக்கிறதுனால இது வந்து என்னது? Spindle speed, a 25 centimeter diameter bar. So capital D is equal to 25 into 10, 250 mm. Speed N is equal to 65 rpm. How much time it will take to machine a 45 degree by 3.125 mm chamfer? Speed கொடுத்தா 45 degree ல இந்த distance 3.125 mm க்கு இந்த distance க்கு chamfer பண்றதுக்கு எவ்வளவு டைம் ஆகும்? So your length is 3.125 and your feed is 0.3. Same formula, T is equal to L by F into N. 3.125 divided by 0.3 into 65. So 0.16 minutes. So this is your answer. Right. Now you tell me please, how many formulas are there required for solving machining time for turning operations? Please respond. No one is there, it seems. இருக்கீங்களாப்பா?
சரி சார்.
இருக்கீங்களா? எத்தனை ஃபார்முலா யூஸ் ஆகுதுப்பா டர்னிங் ஆபரேஷன்ல? டேய் வாய் திறந்து பேசுங்களாண்டா. Can you able to hear the question what I am asking you? Say yes or no. Kindly use your mic to respond, please.
Yes sir.
Yes sir.
Yes, how many formulas are there for turning? கவனிக்கல. Raghu M has left the meeting. Mark him as absent. Who is the representative present? Raghu M. He has left the meeting. Mark him. Right. So this is about chamfering. So the facing operation we will see in next class. Okay. Facing, knurling and all we will see in next class. So with this we stop the session today. The response is very poor. Thank you.